start our day though with one of our favourite friends from Mars Day, David Parker. That's David Parker. He's the Director of Human and Robotic Exploration at the European Space Agency. Now, if you have questions for David as we go through his presentation, please do put them in the Q&A box. So not the chat, put them in the Q&A, and we will be firing all those tricky questions to him at the end of his presentation. But for now, welcome, David. Good morning. We can't actually hear you, but I'm hoping that other people can. I'm lip reading, and you said good morning to us, so fingers crossed.
Do you hear me well?
Yes,
I'm just checking.
We've got you.
Yeah.
Fantastic. Welcome.
Hi there. Great. This is fantastic to have a chance to kick off the Mars Day this year. I'm really looking forward to all the events during the day. I'm sure it's going to be a big success. So thank you so much for letting me be part of it. My name is David Parker. I'm the Director of Exploration at the European Space Agency. As I said, my name is David Parker. I work at the European Space Agency. I'm based in the Netherlands, but the European Space Agency is an organisation that works all around Europe for promoting space and space technology and bringing space down to Earth as well. So I'm going to talk a little bit about our space exploration programme and how Mars fits into that, and also about what we're doing in exploring other destinations and things that the European Space Agency has done in the past. So the European Space Agency is an intergovernmental organisation. That means it's different countries working together on one programme. It was set up back in 1975. And if you count all of the flags at the bottom of this slide, there are 22 member states. There are also 4 smaller countries around Europe that are cooperating with the European Space Agency. And we also cooperate quite closely with Canada, and Canada shares in some of the programs of the European Space Agency. And our purpose is to provide and promote, for exclusively peaceful purposes, cooperation among European space states for space research, technology, and their applications. So ESA has been going, as I said, for more than 50 years, and with 22 member states. Now we have sites all around Europe. I'm based in the Netherlands, which is the main technology centre for ESA. There are more than 1,000 people working here. But we have sites, for example, in UK, near Oxford, at Harwell, the European Centre for Space Applications and Telecommunications. And also we have our spaceport in French Guiana in South America. It's a big organisation, and our budget is growing, and it's grown quite a lot more recently, and we invest about 7 billion euros a year in space activities, with more than 100 satellites designed, tested and operated over the years. But I'm going to talk specifically about space exploration in a moment, but it's important to understand that we're one of the few space agencies that does every kind of space activity. We're looking out into space, deep space with astronomy missions, looking at the history and origins of the universe, but we're also looking down at planet Earth. We have a very big program of activities based on Earth observation, so understanding climate change, understanding the way we are using and affecting planet Earth, which is, after all, our only home. We launch things into space, but we also navigate in space with a Galileo program that provides global navigation. If you have a modern mobile phone, you are using the Galileo satellite signals to help you navigate. We also support the development of improved communications across Europe and around the world. Every kind of satellite communications is really important for developing our economy and for everyday applications. And it's all underpinned by basic technologies, the technology to work in space and the technologies you need to operate in space. But I'm going to focus on the science and exploration parts of our program now, and just give you 3 examples of missions that have been or are about to explore our solar system from the scientific program of ESA. And the first is one that has a special place in my heart. I was in the control room in Darmstadt in Germany on the 14th of January 2005, when the Huygens probe, named after the famous astronomer, slowly parachuted into the world of Titan. Titan is the largest moon of Saturn, and Huygens had travelled, hitchhiked aboard the NASA Cassini spacecraft, more than nearly 1.4 billion kilometers away from the sun to find a strange new world, Titan, which has an atmosphere, and it has rain, and it has lakes, but they're not of water. They're of hydrocarbons, ethane and methane and other hydrocarbons, because it's incredibly cold. And so Europe has made the most distant landing on another planetary body with this mission. And it was a real high point for ESA's path of exploration. I was talking about the Rosetta Comet mission in 2014, a real high point of exploration of our solar system, and a mission that landed on what is a primordial body. You could think of it as leftover materials from the start of the solar system, and therefore very interesting to understand where water came from, its distribution through our solar system, and also the kind of basic chemicals from which life is built. So a very important step in understanding our solar system and its history. Now, a mission that's going to be launched just in a month's time is JUICE, the Jupiter Icy Moons Explorer. Is the next scientific mission. It's launching on the 13th of April, but it will take 9 years to make its journey to the Jupiter system, and with a particular goal of exploring 3 of the most exciting moons of Jupiter, Ganymede, Callisto, and Europa, which in different ways we believe have oceans. For example, Europa is thought to have an ocean that lies beneath a frozen crust. And that's why Europa is one of the destinations that's interesting to understand for its potential for past or present life. Again, there is liquid water there because the squeezing of Europa and the other moons by the massive gravity of Jupiter has the effect of melting what should be just ice and turning it into liquid water. So this is going to be a very exciting step in understanding our solar system, and JUICE launches just in a month's time. Now, a bit of history of exploration. I come from the city of Bristol, I live there, and at the city of Bristol we celebrate an explorer called John Cabot, who was actually an Italian called Juan Caboto, who explored in a voyage in 1497 out across the Atlantic Ocean in search of trade routes to China. But where he actually landed up was the place that we now call Newfoundland, or Newfound Land. But I like this picture because it shows the idea of exploration. It's a loop out to a destination. It's exploring that destination, moving around, understanding where you are, and then making the journey back again. And true exploration involves going there and coming back again. Especially for our human explorers, our astronauts, we definitely want to bring them back. So perhaps the greatest success of exploration was the Apollo moon landings. I was, and I always have to try and remember, 6 years old when Apollo 11 landed in July 1969, the first of the Apollo missions to explore the surface of the moon. That first mission, the astronauts were there for just a few hours and came back again. Subsequent missions, they extended their exploration with the help of a rover and going out greater distances from the lunar lander and bringing back samples of rocks. And I like this picture because it's the only time we sent a scientist, Harrison Schmitt, or Jack Schmitt as he's known, to explore the moon, and he was a trained scientist, a geologist. And the rocks that we brought back from the Apollo moon landings are still being studied. Some of my team have recently been opening a sample of material brought back from the moon on Apollo 14, which have never been opened in the 50 years since they were brought back. But now we're able to use new technology and science in order to understand and use the materials brought back from the moon. In the future, we'd like to bring back material from Mars and other planetary destinations in order to deepen our understanding of our own solar system. When I was young, tea came in little packets and used to have picture cards, 50 picture cards to collect of different subjects, maybe the history of Britain, or maybe the history of cars, or whatever it was. In 1971, the set of picture cards made by Brooke Bond, the tea company, was called The Race into Space, and it covered the history of space exploration from 1957 up until 1971. when I was 8 years old. And the very last picture card, and on the cover of the album that you put your picture cards into, was the vision of the first human mission to Mars. This is something that was an idea back then when I was a kid, and it's still a dream and something that lies in our future now, and something that we're very much looking forward to. And it might make you laugh, and I don't know if you can see how the dates on this picture of the orbit transfer from Earth to Mars. The idea was the ship would leave Earth orbit on November the 12th, 1981, and reach Mars on August the 9th, 1982, and then come back again by the end of 1983. That dream of Mars exploration was beyond the technology and certainly the financial means of those days. But it is absolutely still our horizon goal for exploration, for human exploration today. And we are making the first steps towards that goal right now. So one of the things I always like to talk about is, why do we bother exploring at all? Why do we do space exploration? There are 4 good reasons that I present you here. A lot of it is about understanding and obtaining new knowledge. It could be new knowledge about the solar system, but it also can be new knowledge about the way the human body works in the space environment, about biology, about materials, and all sorts of capabilities and knowledge that we can use back here on Earth. So everything we do for exploration is not just about spending money and going out there, it's bringing knowledge back to planet Earth. And to do that, we have to develop all sorts of new technologies in life support systems, in propulsion, in computers, in artificial intelligence. And all of that is not spent up in space, it's spent in companies and in research institutes and universities all around Europe. And everything we do in exploration, we do in global partnership. We work with countries all around the world in exploration, and working together in ESA, the 22 countries, is a fantastic experience to have all these different people and different backgrounds working together. And one of the things we hope to do, and hopefully I'm trying to do today with this, this presentation, is inspire the next generation, because I was inspired as a kid by the exploration of the days of Apollo and then the space shuttle. Now we're planning the next steps of going forward to the moon and on to Mars. And the astronauts we have today, and you'll meet Tim Peake today as one of the astronauts who's worked in the European Space Agency, are fantastic explainers of science and technology, and people that can hopefully inspire the next generation. Because the space industry is growing, we need more people to come and work in it, and we need to encourage young people to come and join this exciting world of space. And one of the places we're living and working in space today is the International Space Station. The space station is 400 tons of technology that is orbiting the Earth every 90 minutes and has been permanently crewed for more than 20 years, which means there have been people living and working off-world, off our planet now for more than 2 decades. And this will continue for the rest of this 2020s as well. They're doing all sorts of experiments. Dozens of astronauts have done hundreds of experiments on behalf of thousands of scientists around the world for the past 20 years, bringing capability and skills which we really need. Now, our exploration program is based on exploring the Earth, but also the Moon and Mars, because these are places where we believe human beings will live and work in the future. We've been living and working on planet Earth since the beginning of humanity, and living in space for 20 years aboard the space station. In the future, human beings are going to live and work on the Moon and one day on Mars, but they're very different destinations. The Moon is small and has lower gravity than the Earth and no atmosphere. But on the other hand, it has hardly changed for billions of years. So it's a fantastic place to unlock the history of our solar system. On the other hand, Mars has gravity about 1/3 of the Earth. It has an atmosphere, but one that doesn't contain oxygen. And it is a planet that's changed out of all recognition. Once upon a time, it was covered with oceans. And at some point, we think about 3 to 3.5 billion years ago, those oceans were lost. Some of it was frozen into the earth, into the soil of Mars. and a lot of it is retained in the polar ice caps today. So it's a fascinating world that is constantly changing. It has an atmosphere, it has weather, it has seasonal variations of that weather, it has climate. All of these things we want to understand more about. So we have now an exploration program in Europe. I won't go into all of the details of this, but we're working on science and technology for all of the destinations, continuing to work on the space station, preparing to explore the moon once again in partnership with NASA through the Artemis program, and building robotic explorers to go to Mars and indeed come back again. So let's talk about the moon as the next place where human beings will live and work. For us, it's a picture of robots and humans working together, and this is what this little cartoon is trying to express. But to go to the moon, we have to build rockets of a size that we haven't built since the days of Apollo, giant vehicles such as the new space launch system. One of the reasons we want to go to the moon is to understand things that we didn't know in the days of Apollo. Satellites tell us now that there is probably quite a lot of water frozen in the South Pole, the polar regions of the moon, the North Pole and particularly the South Pole, because there are places on the South Pole which are so cold the water frozen there will stay there pretty much forever. And water is interesting because it's the basis of life. Water is also interesting because we can convert it into something that we can drink. We can extract oxygen from it. And it's also the basis of oxygen that we can use in our rocket engines to go further into space. So the moon is a destination for science, but also a place to live and work off-world on our journey to Mars. Oops. Now, the new era of human space exploration has just begun. Last November, we launched the first mission of the Artemis program. This is the new return to the moon based on the giant new space launch system, this huge rocket, much bigger than anything we've flown since the days of Apollo. And our spaceship to go to the moon is called Orion. It's on the top of the Space Launch System rocket, the SLS. And this Orion spaceship has two parts to it, a crew module built in the United States and a service module built in Europe. The crew module is where the 4 astronauts will sit, and the service module provides the power, the propulsion, the water, the oxygen for the astronauts on their few days' journey to the moon and then the return back again. And the first mission was a fantastic success, and I think at the end of my presentation, I think their team are kindly going to show a little video showing that mission collapsed into just a minute or 90 seconds. But one of the places we are going to go to with our moon ship, this little chart shows you that first mission where we went out to the moon, and in fact beyond the moon, we went into orbit, a special kind of orbit beyond the moon, to demonstrate and test our spaceship. But with the first mission, there were no astronauts aboard, but there was a passenger, and the passenger was Shaun the Sheep. Shaun the Sheep was the first European astronaut to go into deep space, and he has safely returned back to Earth and has been returned back to the Space Technology Centre here, and is coming back to the UK very shortly. And you'll see Shaun at the end of our little video. But what we're building as our destination for Orion and for our Artemis program is a space station around the moon that will support robotic and human exploration around the moon for the next 20 years. It's kind of our base camp for exploring the moon, a permanent facility, a little space station with laboratories, docking modules, and the ability to control a robot arm to move things around, all the things you need to live and work in deep space for the first time. And this is a huge step. And again, Europe is building about half of this mini space station around the moon. But one day we have a vision of building a sustainable exploration of the moon with a moon base. And based on the robotic missions we're doing now, the astronauts going down to the surface of the moon for a few days, then a few weeks. One day we'll build a permanent international human research station on the moon. And that's an idea that we've been working on for some years. We've even got the design of what that moon base could look like. We will protect the astronauts from the radiation in deep space by using the lunar soil, building bricks out of the lunar soil and covering our space moon base to protect the astronauts. But we don't want to leave it there, and today is about Mars, and I don't want to forget the red planet. The red planet is a fascinating place for all sorts of reasons. Its history, the way that it has changed, what we know about its similarity to planet Earth, and the big question, why is there life everywhere now on Earth? And as far as we know, and I say as far as we know, there is no life on the red planet today, but it had all the raw materials, all the chemicals, the water and everything needed to produce life billions of years ago. And this is why it's so important to go there and explore properly. We've been exploring Mars here at ESA with our first Mars spacecraft, Mars Express, which was launched in 2003 and is still working very nicely. And a big orbiter called the Trace Gas Orbiter, which has been particularly looking at the atmosphere of Mars, trying to understand whether there are particular chemical species like methane and oxygen and other gases in the atmosphere, but also mapping the subsurface water using a special kind of instrument that can get below the surface of the planet and map the water that we see there, and we do see it there. So again, water is important for life, and the origin and presence of water on the red planet is something of great interest. But to go down to the surface of the Mars, several NASA rovers have done it already. We've had a long story and a big challenge to get our robot astrobiologist, the first rover designed to actually directly search for the evidence of past life. It's called Rosalind Franklin. It's named for a famous British scientist who worked on the discovery of DNA back in the 1950s. And it's designed to get below the surface of the red planet with a drill, bring samples up and put them into a tiny analytical laboratory. It's shrunk something that would normally fill a big room back on Earth into something that fills just a few suitcases and take that to Mars. This exciting mission is now planned to launch in 2028 and is the first attempt to search directly for past life on Mars. But one of the other things we want to do is to bring Mars back to Earth. And we're doing that with another mission working together with our friends from NASA. It's called Mars Sample Return. You'll hear a lot about that, I'm sure, today. And that mission is underway. The first 10 samples have been put of Mars soil, have been put into little containers, not much bigger than a test tube you'd see in a chemistry lab. And they're now sitting on the surface of Mars, waiting for a future NASA lander and a European mission to come and collect those samples and bring them back to planet Earth. And you remember I said we were still analyzing the samples we brought back from the moon with Apollo. Well, these samples will come back to Earth in 2033, and then they'll be examined by scientists for the next 50 years. So maybe you will get to work on the samples from Mars. Every single grain of dust will tell us something about the history of the red planet, and is really the most ambitious robotic exploration mission ever attempted. But it's also a little bit like a scaled down model of what a future human mission to Mars would look like when we can eventually send astronauts there. And that's really the goal. I come back to the history of exploration so far, and our target one day to send humans to Mars. It's the vision that we have. But the explorers are not just the astronauts that go there. We learn how to be explorers back here on planet Earth. Here we train our astronauts in remote locations. This is Lanzarote, where a location that looks like the planet Mars, and where we can train our astronauts. But we also go to remote locations like Antarctica. There are research bases in the frozen south of Antarctica, where we can develop technologies and science, and also understand how human beings can live and work so far from the rest of humanity. So the research stations in Antarctica are a little bit like a model, an analog of living and working on the moon and living and working on Mars. And so again, young researchers go there, they arrive in the Arctic autumn, spend the winter in the darkness of the Antarctic and come back with their results and their science and their discoveries. And it's a remarkable place to live and work. But it's not the only place to live and work. We can also live and work back in our laboratories here on Earth. And I wanted to come to the end of my presentation by showing you two young researchers of the European Space Agency working on how to turn material of the moon into metal and oxygen, preparing for us as human beings to live and work on the moon and prepare one day to live and work on Mars. And these young people have ideas and that I couldn't have been dreamed of when I was at school 50 years ago. And now they are developing the skills that will take humanity onwards to this journey of exploration. And Europe is really at the heart of it through our exploration program. And I very much hope that some of you will have the chance to participate in the future of Europe's journey into exploration. So thank you very much for your attention, and I hope you have a great Mars Day. Thanks for the chance to talk to you.
Thank you so much, David, for that wonderful introduction to what ESA is doing. Really comprehensive. We've got loads of questions that have come through for you so far. We're sifting through these reams of questions, but actually lots of them are kind of on a common theme. So a question from Mr. Metcalf for you. What is the temperature on Mars? Will it be cold?
Yeah, it can get extremely cold and frozen during the Martian night, and even colder on the moon, and at very high temperatures during the day. So one of the challenges is absolutely how we survive the heat and the cold on Mars. One of the challenges for our rovers is that in the Martian night they can freeze. So we have to have heating devices to keep them toasty warm during the Martian night.
I like this idea of a little hot water bottle for our rovers. But I think one of the things that you touched on, which I think a lot of people have been writing about because maybe they weren't familiar with it, is the idea that we might have ice on Mars, and you've shown some images of polar ice caps, but liquid water on Mars is quite a recent discovery, isn't it? Can you tell us a little bit more about that?
Well, it's still a controversial subject whether it's possible to have liquid water on Mars. So there's no definitive answer. There is evidence of liquid-like effects going on Mars, but they may be actually a particular kind of soil behaving in a way that looks like water in the way it behaves. But clearly, in the past, yes, there was absolutely liquid water on Mars when the atmosphere was much, much thicker than it is today, because we see the evidence of rivers and river deltas and oceans on the surface, and that's where we want to send our rovers. So the Rosalind Franklin rover is targeting a particular ancient lake bed, exactly because we think we see from orbit the kind of soils that we see on Earth that we associate with water. And the Perseverance rover that is gathering the samples right now is moving up a river delta, exactly to examine the kind of materials that were made in the presence of water 3.5 billion years ago.
Well, I guess that's the sort of million-dollar question, isn't it? Is what happens? I mean, it's hard for us to imagine Mars looking anything like having an atmosphere, having water. You know, we look at it today and it just looks kind of cold and dead and a bit red. But clearly it hasn't always looked that way. So do we know how it all ended up
Well, the best theory is associated with its magnetic field. So life on Earth is dependent really on the presence of a magnetic field. The liquid core of the planet produces a magnetic field that helps protect us from the radiation of space. If we were out, even if we could breathe in space, the radiation environment of space is extremely damaging to life. Mars I like to say, it's kind of broke down. We know we see evidence of remaining magnetic rocks and material on Mars, but it doesn't have a fully active magnetic core and field. And so equally, the atmosphere has been stripped away by the solar wind over millennia. And that's information we've got from our Mars probes like Mars Express, seeing how that process is still continuing today. So it's probably linked to the fact that Mars is just a bit too small compared to planet Earth. We always talk about the Goldilocks zone. Venus is too hot and too close to the sun, and the atmosphere is like a climate runaway, very unattractive, very thick atmosphere, but completely unsustainable for life. Mars is just a bit too small and a bit too far out from the sun, and we're just very lucky to be in the safe place, just not too hot, not too cold, just right.
And I suppose that leads us on to the question in terms of humans going to Mars. So we've got Kaz from ADL and Form 11E at NWA, and they ask quite a similar question in terms of the technology to get humans to Mars. Will that be similar to the technology that we use to get humans to the moon? And when might that happen? And could people that are alive now actually live on Mars in the future?
Could we?
Could we go to Mars, David? Is that okay?
Yeah, next week. Just book your tickets. Yeah, so the answer is a lot of the technology will be similar, but there are still remaining challenges. So the propulsion, the rockets we need to get off the planet and head off to Mars are similar to what we're developing now to go to the moon. They'll need to be bigger. The cartoon or the picture card I showed you earlier was based back 50 years ago on thinking about using nuclear rockets. So nuclear rockets allow you to go a lot further, a lot faster than the chemical rockets and the electric propulsion we use today. So that will be very helpful. But I always say the biggest challenges are not the rockets, it's keeping humans safe. It's providing the food and water, the supplies, for the year's journey there and the year's journey back again, whereas it only takes a few days to get to the moon. You and I use 100 litres of water every day. It's 4 litres of water a day on the space station. We need to get that down even more with recycling technologies. So, but will we go? Yes, I'm convinced by the middle of this century, humans will be on the surface of Mars.
Oh, middle of the century, that's interesting. We've had lots of questions about timescales, but I think people are quite excited.
They have, and I suppose one question that has come in from the British Online School is terms of will astronauts eventually be able to explore places through VR connected to a rover? So could we, I suppose, go to Mars without going to Mars?
Yeah, that's a great question. I really believe the combination of humans and robots working together is going to be part of the secret. For example, we want to explore very remote locations on the moon, which might be permanent darkness, permanently shadowed, extremely cold. We've already demonstrated controlling robots on the Earth from the orbit on the space station. That's actually Tim Peake did some of those experiments a few years ago. And so we can imagine doing something similar on the surface of Mars to start off with, from orbit around Mars. Sending the robots into the very dangerous places, but scientifically interesting places before the humans go.
So I guess we're going to have to wrap up shortly, but we have had lots of questions about Sean. So we would like to know a little bit more. Was Sean, were there lots of instruments on Sean to make measurements? Was Sean just along for the ride? Where is Sean going?
Yeah, well, so Sean, essentially, yeah, he went along for the ride and the view. So you saw in the video, some of the views were amazing. But But we did actually have 2 instrumented human figures as well that were instrumented to measure the radiation environment. But Sean was well protected and safely protected, so he looks great from his mission. So yeah, he's back in one piece.
Excellent. Good to know he was performing some service in the, you know.
I'm desperately trying to think of sheep-based puns, and all I can think of is, did he go to bars? That's all I can, like, it's not great, is it?
Well, he's part of the Artemis program, so we call it, he was part of the Artemis program.
Oh, brilliant. Thank you. That is much better. And I suppose just before you go, David, obviously you have a very impressive sounding job title, Director of Human and Robotics Exploration at the European Space Agency. But of course, years ago, you could have been watching things like that, like our audience that are watching now. So I suppose, how did you get into this? What fired your rocket that led you onto this amazing career?
Well, thank you. Yes, it was absolutely watching the Apollo moon landings, the picture cards. We all made models of spacecraft. There were astronaut toys we had back then, but also some great TV shows, and I can bore you with Thunderbirds and Space 1999 and all those shows of the 1970s that inspired me. But I never wanted to be an astronaut. I always wanted to be the geek, if you like, designing the rockets and making it happen. So the technology and the science is what always fired me.
That's great, and actually kind of points to some sessions we're doing this afternoon about the range of careers in science. It's not just the people that sit on the rocket and go up, but all the people that facilitate that actually behind the scenes, also playing a role in space.
In your words, the people that make it happen.
There you go. Great. Well, David, thank you so much for joining us. We really appreciate your time. Thank you again for that wonderful overview.
Have a great day. Take care.
Thank you.
Thank you. We will.